I made a weather station with my Raspberry Pi Pico W and an environmental sensor. I'll show you how I did it. I started by ordering all the necessary components. That includes a Raspberry Pi Pico W with pre-soldered headers, the BME 280 environmental sensor, and a solderless breadboard for the Raspberry Pi. Once all of the components arrived, I began putting it together. I installed the Raspberry Pi Pico W to the breadboard. Then I realized that all the wires for the environmental sensor had female ends, and they needed male pins so that they could be put into the breadboard. I ordered a connector kit that included the male pins and a crimper tool and additional pins for future projects. Once the kit arrived, I snipped the female ends and shredded a 1/4 inch of rubber from the wire to insert the male pin and crimp it together. I plugged in all the pins to their designated location on the breadboard. The ground to the ground, VCC to 3V3 out, SDA to GP0, and SCL to GP1. Then I set up the Pico W with MicroPython. I plugged in my Pico W while holding down on the boot select button, and the Pico W file opened. On micropython.org/downloads, I scrolled through the images until I found the Pico W. I downloaded the most current version of MicroPython and dragged it into the Pico W folder. I used Thony for my IDE. I found it to be easier than using VS Code for the Raspberry Pi projects. I already have it downloaded, but the process is to download the Thony software and run it. I keep access to it on my desktop for convenience. This project was inspired by this website, explainingcomputers.com. They provide a video tutorial and code for the project. I started my project by trying to use their code. I copied it and I saved it to my computer and then added it to the Pico W. I made the mistake of making it the main Pi code from the beginning without testing and debugging. When I edited the main Pi code, it caused the Pico W to lock. It would then receive the error, process ended with exit code 0. I searched till the end of the internet and finally found a blog that someone wrote that stated that the only way to get it unlocked is to flash to Pico with the factory settings software. Once I did that, I was back in business. Next, I downloaded the BME 280 module. When I did a search for the BME 280, there were multiple options. Only through trial and error, I found out that it must be the MicroPython BME 280 package used in order for the environmental sensor to work properly with the Pico W. After that, I ran the code in high hopes of getting everything to work properly. Instead, I received another error. For this error, I ended up using ChatGPT. That led to a process of testing to make sure the socket would close properly after the script ends. Once I defined a cleanup process in the code, I received a Pico IP address that I was able to put into the URL. This accessed a web page that said, "Hello World." Going back to my code, you can see that this is the result that is expected at this point. Now, I wanted to get the sensors to start reading weather. I asked ChatGPT for more help, and it gave me a code to run a diagnostic check to make sure the sensors were communicating with the Pico W. I saved the provided code as sensors.py and ran the code on the Pico. This proved that the sensors and all the pins were correctly installed and producing data as it should. I asked ChatGPT to take all the code that I've been working on and organize it in the most efficient fashion. I saved the results as my main Pi code. Once installed on the Pico, I ran the code, and the results were confirmation that the Pico was connected to the internet and a link to the IP address that would produce results of the environmental sensor. Let's quickly review the code. At the top are all the modules, then my Wi-Fi credentials, the Wi-Fi connection process that retrieves the IP address assigned to the Pico W, and will print connecting to SSID. If it does not, after 10 seconds, it will print failed to connect to Wi-Fi. This next section initiates the I2C, or the Inner Integrated Circuit. It is a protocol that allows the Pico W to communicate with the sensors. The next line allows the BME 280 library to initiate the sensors at a specific address. This next section takes the sensor readings and formats them into a HTML page and refreshes every 10 seconds to provide updated data. The serve function retrieves the temperature, pressure, and humidity data from the BME280 sensor, generates the web page using the webpage function, and sends it back to the browser as a response. It also prints the request to the console so I can debug it if needed. The final section of code prints the IP address and opens a socket. It calls the serve function to continuously listen for and respond to HTTP requests. I felt like this project needed something more, so I updated the HTML to add color to the background and some images. I also added a conversion from Celsius to Fahrenheit. If you look at the code now in the HTML section, you see that I added the light blue hex color code. I then added some cloud images, and then I added their location on the screen. I saved the cloud images to a public image hosting service called imager.com. Then the margins for the weather report are set. The next part describes the animation of the image of a boy flying an airplane. It describes its movement from right side of the screen to the left. This movement is achieved using CSS keyframes. The final code displays weather data and the animated image. I placed the final code in my GitHub repo. If you want to take a look at it, you can view the raw form under the README file. The last thing I did for this project was hook up a battery pack to power the Raspberry Pi. You can order these at Walmart. They're fairly inexpensive, and they last for about 5 hours. I unplugged the Pico from my computer and plugged it into the battery pack. The back of the breadboard has adhesive to it, so I might just stick it to the battery pack. I accessed the IP address and found that I was still getting weather reporting from my device. Now I can put this outside or inside anywhere in my house as long as it has Wi-Fi connection. I had a lot of fun doing this project, and I enjoyed the experience that I received from getting into the code and learning how to combine Python, HTML, and CSS to create a web page. I hope you enjoyed this video and it inspires you to start a project of your own.